Okay, integrating this one here. I'm just going to split it up. So x3 dx minus 2, 1 over x dx plus cosec squared x dx minus e minus 3x dx. To integrate the first one, x4 over 4. Derivative is on top, so just log the bottom. Cot goes to minus cosec squared. So we need a minus in here, so balance it outside. So we'll just go back to cot x. For this one, I need the derivative in front. Derivative is a minus 3, so balance it outside with minus a third. So outside I've got plus a third, and the derivative disappears, and just don't forget your c. For this one, sine goes to cos. So we've no sines to worry about there, that's grand. Need the derivative in front, balance it outside. So when you integrate it, it's going to go back up to sine. Your wee limits, so it's a half sine pi over 3 minus sine 0. And sine pi divided by 3 is root 3 over 2, and that's 0. So the whole thing works out to be root 3 over 4. Okay. Same year, only I'm going to have a look at the C4 paper here. So number 4 is quite an interesting one. You're looking for the volume. Now this is the bottom of your tank, and you want to have a depth of 15. So your first limit is minus 12, but you're only going up as far as 3. And then it's y squared, sorry, pi y squared. You square that, the root just disappears, dx. So to integrate that, 144x minus x3 over 3 and minus 12. So putting in your 3, 144 times 3 gives you 432, minus, that's going to give you 3 squared, which is 9. Take away 144 times minus 12 gives me minus 1728. A minus cubes a minus, another minus gives it a positive. So 12 cubed divided by 3 gives me 576. So 432 minus 9, add 1728 minus 576 gives me 1575 pi centimetres cubed. And what is the problem with this? It's going to have a round base. So it has a round base, not a flat base, so it's not going to stand. Okay, the next wee one is number 8. It's a nice wee question, this one. It's integration by parts. And as you know, when you're doing integration by parts, u is always the easier one unless there's a log. And if there's a log, that is what you choose your u to be. So my dv by dx is this one. So differentiate this, you get 1 over x, integrate this. So the left, sorry, the right hand side of your formula is uv minus v du by dx dx. So it's uv. That's a 2, sorry. So u is log x, v is x squared over 2. I'm just going to put it in front there so don't log it. Minus v times du by dx dx. So tidying this up, it's x squared over 2 log x minus x over 2 dx. So to integrate the far side, you add 1 and you divide by it, and don't forget your c. Part 2, we're going to play around with the log rules. Do you remember one of the rules of log is if you had a power, you could bring it forward. What I'm going to do here is I'm going to bring this power forward. So it's 2x log x dx. I could just put that 2 through the integral sign, and all of a sudden I have got my part 1, and your answer to part 1 was up there. X squared over 2 log x minus x squared over 4 plus c. So you can write your answer as x squared log x minus x squared over 2 plus 2c. Some people actually write that as a different constant. So you could write that as x squared log x minus x squared over 2 plus d, or any other random constant, doesn't matter. For this one, I'm going to think of the log rule. Do you remember this one here? If you're multiplying two numbers, you can separate them out and add the logs. So I'm going to write this as log 3 plus log x. Now I'm just going to times through by x. So that's my first integral, and there's my second integral. Log 3 is just a constant, so it can go through the integral sign. Here is part 1, so just pop your part 1 answer in there. To integrate that, you add 1 and you divide by it. So, it's a 2. And it's times it by log 3. Plus, this already has been integrated for you in part 1. And that's you finished.